Assalamu alaikum. Today we will do the question that it is known that IQs are normally distributed with mean 100 and standard deviation 10. If an individual with IQ of 130 or above is classified genius, what is the probability that a random selection yields a genius? So this is the distribution of the IQ level in which you can see the title of the figure is f of x. So it's a density plot of the IQ level, which is normally distributed with mean 100 and the standard deviation is so the range is 75 to 135. Suppose we are taking its range 75 to 135. So minimum requirement, so the IQ level of 130 or above are genius. So 130 figure is more than 100. So it must be on the right side because it's a number line starting from minus infinity to plus infinity. In the middle, it is mu 100 and 130 must be on the right side of the 100. So if we plot 100 side of the plot, its value would be, for example, here at this point, it's 130. It's 130. And above, it means we have to shade the area which is on the right tail, starting from this point, from this arrow up to the plus infinity. So the shaded area would be now this one. And the point is 1, and the shaded area is for the genius. The point here is 130, and the people who are here are considered as genius. So these are considered as genius. This is the criteria for the genius. Now we will write it. We start the solution and write here if x is normally distributed with mean, if is normally distributed with mean, in our case mean is 100 and variance which is 10 square, so we will write it as 10 square. 10 is the standard deviation, and the probability for the genius is required. Is required. So at the point x is equal to, this is our value 130, we have to find the z score at this point. So z, we know the z value is obtained by its standardized expression, which is as x minus mu over sigma. So our sigma and mu are given here as 10 and 100. So mu is all three values will be substituted in it. So x is 130 minus then mu, which is 100, and whole divided by sigma, which is 10. So its answer would be 30 by 10, which is 3. So it would be 3. Now we have to find the probability that x should be greater than equal to, because x should be capital because it's random variable. Here, these are the values of the x and z. Therefore, we can write it as small z and small x. But here, it's a random variable. So always write capital X with the probability. It should be greater than equal to 130 for the genius, and it will be converted now in the z-score probability. And again, z should be capital here, and the value of z is here 3, so we will write it here as 3. And whenever there is a greater sign here, it's a greater sign, so we have to convert into and the 1 minus phi of z, since we know that the total area under the curve is 1, and the table gives you the phi of table uh, gives you the area starting from the minus infinity to that point. And this area is called as phi, capital Phi. This area is capital Phi of z. In our case, z is 3, so this area is phi of 3. From the table, we can get this area. But this is not actually the requirement. Requirement is the shaded area on the right tail. So we have to subtract it phi of 3 from 1. So we can write it as 1 minus probability. Here we can write it as 1 minus probability z less than equal, less than, that should be capital, so z less than 3. And we can write it as 1 minus capital Phi of 3. And from the table number 9, we can see its value at 3, which is not on this page. So come to the next page. Its value is not again here. So on the next page, its value is this one, 3 against the 0.99865. So we will write it here, 1 minus 0.99865. And after the calculation, we will write it here. Anyway, okay, right here. It's solution 0.00135. So we will write it here 135. Okay, this is the solution of R. What is the probability? We have to find the probability. If the requirement is percentage, then we will multiply it by 100% and get the answer in percentage. Now come to the next part of this question. This one. The mean inside diameter is the mean inside diameter of sample of 250 washers produced by a machine is 5.05 millimeter, and the standard deviation is 0.05 millimeter. The purpose for which these washers are intended allows maximum tolerance diameter of 4.95. This is the interval which allows the tolerance. So maximum tolerance exists between these 2 points. Otherwise, washers are considered defective. So beyond this limit, 4.95 to 5.10 is the accepted tolerance limit, and beyond this limit means 4.95 below this point and 5.10 above this point is considered as defective. Determine the percentage of defective washes produced by machine assuming the diameters are normally distributed. So in our solution, we can write it as X is normally distributed with mean 5.05 and standard deviation is given 0.05. So variance would be 0.05 square. And this is the figure in which uh, this one. This is our figure in which the middle point is our average, and average is given as 5.05. So we will write its mu here, this one 5.105 is in the middle, and the requirement is the tolerance interval is 4.95 to 5.10. So these 2 points are also mentioned on this number line. Number line is for the x normal variate. X is mentioned here, and this is the density curve. So f of x is the title of this curve. Now we have to find the probability of defective criteria. So at these 2 points, initially we have to find the z-scores. So z is equal to x is equal to 4.95. The z-score at this point would be z is equal to 4.95 minus its mean, which is 5.05, whole divided by its sigma, which is given as 0.05. So we will solve this expression here. Its answer is -2. So we will write it as it's -2. Now the same solution will be obtained for the second point, which is 5.10. So we will change our value here, 5.10. So answer is now 1. So we will write here 5.10. Here we will substitute in z score 5.10 minus mu over sigma, which gives us the value +1. Obviously, 5.10 is on the right side, so its answer is 1, positive 1. 4.95 is on the left hand of the mean, or the left tail, so its answer is -2. If we draw a number line here for the z-score, for example, if we plot a number line here, this point, this would be, for example, we write it as z. And the 2 points here at 5.10, which is here, this one, 4.95, which is here, so this one, corresponding to these 2 points here at z, here in the middle. Obviously, there should be 0 in the middle of the z-score, z line. So it must be its mean mu, which is 0. Its answer is after calculation 1, and its answer after calculation is -2. Now we have to find the probability for the rejected uh, washers. So for the rejected washers, it must be start from -infinity to 4.95, because accepted range exists between the 4.952, this is our accepted range. But we have to find the rejected range, so it should be on the left tail, minus infinity to this point, 4.95, and on the right side, it's again the rejected area because it's not included in the interval. The accepted interval is in the center of the distribution, which is 4.95 to 5.1. And for the rejected effective area, we have to go beyond this limit. So beyond this limit, the areas would be this one. So there are two ways to find this area. Total area is 1, and this area is obtained by phi of minus 2. If we will locate minus 2 in the table gives us the shaded area, this one. So we will obtain this area directly by phi of minus 2. And for this shaded area, we will write it as 1 minus the point at 1 gives the area from minus infinity to 1 is this one. For example, at 1, the table gives us this area. But the requirement is this one. This is our required area. So after subtracting from 1, we will get this right shaded area. So we will write it here. It's phi of 1. So by adding these two shaded areas, we will get the rejected probability. So we will write here now. Now I'm going to clear all lines and come to the solution. And in the solution, we will write here probability for rejected washers. Rejected or defective washers. Which is written as here x should be less than 4.95. All washers having diameters less than this one are rejected, or x the tolerance more than 5.10, those are also rejected. So we can write it as in the terms of z probability z, capital Z, less than 2 or capital Z greater than 1. Now we will write it as probability. We now separate these two probabilities, and after separation we can write them as Z less than 2, Z less than 2 plus probability, because or mean we have to add these things. Z greater than 1. So whenever there is less sign, we can write it as phi, and greater than, it converted into 1 minus c. So in the next step, we can write it as it's phi of 2 plus 1 minus phi of 1. Now from the table, we will write the values here. So phi of 2 is from the table, it's phi of 2 On the first line, it's point phi of not 2. It was minus 2. Okay. So on the first page, phi of minus 2 is this one. Not here. Phi of minus 2 is this one. 0.02275. 0.02275. Was minus 2. So minus 2. Here it's minus 2. 0.02275. Okay. 7275. Now at point 1 on the next page, it's 0.84134. 184 plus 1 minus 0.84134. So we will solve this expression here, and answer is this one, 0.18141. So this is our answer. You can write it as this one. And we have to convert it in percentage. Since requirement is in percentage, in the statement we can observe. Yes, determine the percentage. So we will multiply it by 100%. So 100%. And the answer would be 18.14%. So 18% washers would be rejected, while the accepted are remaining 82%. So this is the solution of the second part. Thank you so much. Allah Hafiz.